All of the electrical components shown in this film are manufactured by high-quality electrical equipment manufacturers and have passed specific listing agencies' requirements before being put on the market. It is not the intent of this film to degrade any equipment manufacturer, but rather to show the possible result of misapplication of the equipment used. Overcurrent protection. Chapter 1. Interrupting rating. The first paragraph of Section 110-9 of the National Electrical Code requires that short-circuit protective devices have a sufficient interrupting rating for the available short-circuit current at the line terminals of the equipment. The National Electrical Code defines interrupting rating as the highest current at rated voltage that a device is intended to interrupt under standard test conditions. Note the term standard test conditions may not always reflect field conditions. The IEEE Standard Dictionary of Electrical and Electronic Terms defines interrupting capacity as the maximum short-circuit current that a device can safely interrupt. The following tests will utilize various overcurrent devices to illustrate the importance of having sufficient interrupting rating and how to properly apply Section 110-9 of the Code. This is a one-line diagram of the test circuit. In the first test, 20 amp 600 volt one-time Class H fuses with a 10,000 amp interrupting rating are applied to a 50,000 amp 480 volt fault. This is a serious misapplication. Here's the one-line diagram of Test 2. In this second test, a 20 amp, 2-pole, 480 volt circuit breaker with a 14,000 amp interrupting rating is applied to the same 50,000 amp 480 volt fault. Again, this is a serious misapplication. In both of these tests, parts and molten metal could seriously injure an electrician or anyone near the panel. Let's look at the one-line diagram for the third test. In this test, 20 amp time delay Bussman low peak Class J fuses with 300,000 amp interrupting rating are subjected to the same 50,000 amp fault. Notice that the fault has been safely cleared without any damage. The final two tests will illustrate test circuits more closely representing those allowed by test agency standards. It is not the intent of these tests to actually duplicate the agency tests or to evaluate the results of the tests per the standards requirements. Rather, our intent is to show the proper opening of devices which are applied within their marked interrupting ratings. Here's the one-line diagram for the next test, which has wire lengths in accordance with listing agency requirements. The test circuit includes 4 feet of number 12 copper line side wire per pole and 10 inches of number 12 copper load side wire per pole to create the fault. Note that this length of rated conductor can supply a significant amount of the circuit impedance for breakers rated 100 amps and less. This will reduce the available short-circuit current that the breaker is required to interrupt. In this test, a 2-pole 20 amp 480 volt circuit breaker with a 14,000 amp interrupting rating is subjected to a calibrated 14,000 amp fault at the test terminals. Although the breaker has vented, no external damage is evident. This breaker was tested with 4-foot test leads as specified in the breaker listing standards. Leads blown off the line side terminals during a listing test would result in a failure of the test. It is important to recognize that faults can occur at the load terminals of the breakers. When this happens, the additional impedance of the test leads is removed, and the breaker may experience a fault beyond its originally tested value. This is the one-line diagram for the last test. It will illustrate what happens when a fuse is shorted out at its terminals when very high fault currents are available. Modern current limiting fuses may be tested at fault levels up to 300,000 amperes RMS symmetrical at rated voltages. In this test, a Bussman low-peak Class J fuse will safely open a short circuit with 200,000 amps available. The fault was created directly at the terminals of the Class J fuse. In conclusion, circuit breakers and fuses must be applied so that they are capable of safely interrupting the short circuit current at their line terminals per NEC Section 110-9. Inadequate interrupting rating can cause both fuses and circuit breakers to violently explode and become a potential hazard. Modern current limiting branch circuit fuses applied within their interrupting rating will safely interrupt currents of up to 300,000 amperes RMS symmetrical.